Mr. Vivek Singh is a postgraduate civil engineer with over 25 years of experience. Currently, he is the founder of Bill Street, providing project management services in project planning, material engineering, quality assurance, quality control, road safety audit, and solution, technical advisory, and techno-commercial analyst. Before Sir takes the session forward, I request our esteemed faculty, Samir Gujjar Sir, to speak a few words.
Thanks and welcome Vivek sir. I'm just going to take 2 minutes and give you a very short introduction about this course. So this is a 2-year MBA course in infrastructure development and management. So most of the students who are in the course are engineers. Most of them are civil engineers. This course, we are trying to train the students in 3 skills primarily, sir. So that is a project management, a financial management, and a contract management. In addition to this, they are exposed to all the sectors in infrastructure. So roads, railways, highways, ports, buildings, so on and so forth. So after the first year, they have an internship, which is of 3 months, sir, between the first year and the 2 years. So this is a 2-year full-time program. So we are trying to make the students ready so that they are able to actually work when they graduate from this course and take on the challenges in the industry, sir. So that's a short introduction, sir. Over to you.
Thank you. Thank you and welcome all. And thank you for giving me this opportunity to interact with the young ones. This makes me feel young. So thank you for that. So I'm sharing my presentation now. Right away, we will start. So is my presentation visible on the screen?
Yes,
Can
sir.
you see? So after welcoming you all in this course, Sustainable Practice in Modern Day Road Construction Project Execution. So first of all, let me talk about sustainability. We have to remember that for everything we need, everything, whether it is amenity or a requirement or necessity, need, whatever type, we have to be dependent on nature. Even the things to which we call synthetic, they basically come from somewhere from nature, from petroleum products or something. So, and nature has got a limitation to provide you something. So it can be when the need and when this need crosses the limit, then the resources, the natural resources get strained, both for today and for tomorrow, right? So we have to meet our present needs without affecting and saving enough for the future, without affecting the future and saving enough for the future, right? That is sustainability. You will find this definition. I mean, this is a very popular definition of sustainability. I have taken, I have tried to, get into the field of literature, and with all my apologies with Kabir Das, I have made these changes in his Doha to explain sustainability. And if you cannot read Devanagari, you can read here. It says, Prakriti se itna lijiye, jisme kutumb samaye. And kutumb, we call Vasudev Kutumbakam. It's not limited to the family, to our own family. It is the whole world. प्रकृति से इतना लीजिए जिसमें कुटुंब समाए, आज भी भूखा न रहे, भविष्य को बच जाए. So that is sustainability for me, if I can explain it in the easiest term. So, and which again says that we have to meet our present needs without affecting and saving enough for the future, right? So now let's come to construction projects. And of course, because this particular session is on for is I mean the topic is for roads. So my examples will come from roads. Although you guys are all into infrastructure and you must be knowing about other studying about other infrastructure projects also. But my examples will generally be from roads. Generally be. So I have tried to classify the sustainability into two classifications. One is the project specific sustainability concerns and then universal sustainability concerns. The topics or the attributes or the items kept in these two classifications are you will find you will find them interchangeable sometimes because there is a very thin line between what is project specific and what is universal. But I have tried to somehow classify it into two these things so as to uh, present my thought about sustainability to you. Sustainability, my friends, when anybody talks about sustainability, what comes in our mind is reduce, reuse, recycle, isn't it? But today, what I want to tell you, what I want to share with you, that sustainability is even above that, even ahead of, more than that. Sustainability is not limited to. I mean, of course it is, but not limited to this reuse, recycle, and reduce. As an engineer, I don't know. You must have got trained. The sustainability is something which is integrated in your training and education. So let me see how. So here are some project-specific sustainability concerns. First, let us look at what happens during construction. And my first point is economic. The economics. I mean, you must be amazed at how economics has come into sustainability chapter. But my friends, until unless you have money, you cannot develop. And money always has a limitation, whether it's your own money or whether it is government's money, the exchequer. The same money, the same amount of money has to be used to carry out several projects, to make several projects, to make several expenditures. So if you are not spending the money rightfully or mindfully, then you will not be economically sustainable. And my definition of sustainability goes to that level. That's what I said. I will not be limited to recycle, reuse, and reduce. Right. Then comes and one more thing I want to tell you right here because while I was working on this presentation, I had a tendency to speak that this is what is to be done. But actually what I am presenting is what is being done, what is happening, because that's what the topic sounds, that what is actually happening here. So then comes social and local environment. These are actually similar type: economic, social, and local environment. Local environment, except for the pollution and air pollution, sound pollution, and things. These are something. All these things are studied in the same report, and it is called EIA, Environmental Impact Analysis, which you must be knowing. You are a student of infrastructure. So this EIA, I will give you some examples that what is done in these studies and what are the what are the effects, why this is required, what happens, what went wrong, why EIA required. The EIA has been actually promoted long back by World Bank earlier into the project where they used to give loan, but now it has become a part and parcel of each and every infrastructure project, especially roads. So in roads, what happens is that a road is a bund which divides the landscape into two parts, straightway into two parts. Okay, sometimes your village is on this side and your fields are on that side. So you need, making road has got its own advantage, But the disadvantage is that it makes a boundary, a permanent boundary. So this impact analysis has to study that where should we perforate the roads, means providing underpasses. If you see old designs, there were very less underpasses. I mean, it was not studied well or not understood well. Just the road was made and people were facing a lot of problems. Now in the new designs, the you know the this providing underpass is one of the priorities of the designers to understand that where the underpass is to be provided. Even the roads even projects as big as Delhi Mumbai expressway, in some of the packages it was no, realized on a later stage that an underpass is required here, and now the projects have got delayed, and the project price has gone up, the project cost has gone up because of that, because of change of scopes, and change of scopes are actually costlier than the normal construction as far as the rate of the items are considered are concerned. So this has an impact on the completion of the project, on the cost of the project, and if you do it, I mean, if you would have done it, you know, beforehand, this would not have affected the project. But if you have not done it at all, then it will affect the local people and have a negative impact on the local people, and which will in future affect the sustainability. I will come to you on that why I am saying sustainability. Because reconstruction is a non-sustainable act. If you have to reconstruct anything because it has been designed and constructed with less durability or with high maintenance requirement, then your design and construction will not be called as sustainable construction. So from there I mean joining these two lines, that how the design and construction becomes important for a sustainable project. And that's why my next point, ease of maintenance, comes into picture. While you design, you have to see that how will you maintain this facility, and this goes for everything. I mean, for all the projects which we do, with a train, or whether it was a city. I mean, these days these smart cities projects are going on, where maintenance has become very important aspect. And with the design, you have to submit the maintenance plan, the maintenance methodology for that city. So in cities, it is already happening. In highways, somehow now this concept that if you are designing, especially drains and the items which are in median, such as plants, the median plantation in the center of the road. So that is a very, the maintenance of those plants is a very unsafe act during the operation and maintenance period. So people have now started thinking of making some drip irrigation or something at the time of design and construction itself, so that maintenance becomes easier. Number one, ease of maintenance and less maintenance. The other part of that is maintenance should not only be easy, it should be low also. So for that, your construction has to be durable. How to make it durable, we will come in the coming slides. Then comes the human factor. Now, human factors, normally humans are other than these factors like what I said, the requirement of perforation and all that. One very good example I faced as far as human factor is concerned is that I was making a road and it was a bypass, a greenfield section of the project, and one of the village, a particular community of a village, they came to us, and of course because it was a bypass, the road embankment was very high. So, and with the 1:2 slope, of course, it's one horizontal to 2 vertical slope on the slope side, on the road sides. So that and there burial ground was on other side of the road, and there was no perforation given in the design. So it was a real miss from EIA by the EIA people, whoever have concerned, conducted EIA there. So you can understand in India, in our culture, how important this problem was. So these type of things, go mix, and this also contributes to the human factor here. So one thing is all these parts, and the other thing is the employment part, the skill development part, where road construction or any cross-country type of projects have got very good impact. And there are nowadays there are conditions in contracts which encourage or push the contractors to employ local people, locally available labor, locally available skillful people. They push it, and they sometimes even I was in Africa, so there is a clause that how much this much percentage of the total strength should be. Against one foreigner, there must be this many locals. There is some law. There are some laws like that. So those human factors are also being taken care now. That impact of that. The second part of human factor is the people who are working for the project, and they are, far from their homes, working hard, day night, and their condition, they are far from their family, working for you, and the site working conditions are very very harsh. How to be taken care, how to take care of them. Now there is a latest trend that labor welfare has been made up, is being made, in different contracts, it is going on still, is being made a part of the contract itself. I was the project manager for Dholera Smart City project for L&T, and there was a separate, part, the section, this thick a book, which was only for EHS, and at least there were 20-25 pages on labor welfare alone, even giving a plan of labor colony. Going to that extent that they gave a plan that how the labor colony should be, and they've described all the architectural requirements, that per person how much square meters should be made, and all that. So and what are the facilities to be given to them, trainings, this, that, everything. So that is another important human factor which is now being taken, which is an impact, of course, because keeping your labor in a bad and filthy state is not. I don't find it sustainable, because if they are living in bad and dirty conditions, of course their health will get affected, and that will not be an occupational health hazard. It is because of their living condition. So that is another factor to which I wish to add into sustainability list. So, and then comes methodologies and use of local materials and all. So that we will study. We will come to know in our coming slides, that how methodologies and local material and what is being done these days. Now we come to during operations, the project specific sustainability concerns during operations. Very simple. It's very simple. It is being, people now, actually we Indians, we are very poor in maintenance. We can make heavens, but we cannot maintain it. Luckily, we cannot even maintain hell. So the things get sorted out. So first thing which is very important here is early catching and early plugging. If there is a small hole formed before it becomes a pothole, patch it up. Right. So that is, an example to understand this thing. And not only this thing, no stoppage of services. If there is something local going on, we are very fond of sitting on roads and for anything we want from government. So if you have that sense, so that networking, that and not let that happen, because stoppage means jam. Jam means pollution. So that becomes very important if you really want to run, and then taking quick actions, of course. Now, it just came into mind. I forgot to put it into the presentation. The FASTag, which has come in. It is not only a very good service to the road users, but it also adds to the sustainability, to reduce the air pollution of that area where the toll plaza lies. So, and a lot of petroleum, which goes, the petrol and diesel, which gets wasted. While the trucks and cars are standing idle. That is another very good sustainable practice during operations, right? So then comes universal concerns. Of course, universal concerns: air pollution, noise pollution, flooding, and so pollution during the construction, and pollution caused due to the construction. So this pollution, other than air pollution and noise pollution, you all must have heard that recently a road has been made through a tiger reserve, where the I mean it was designed in that tigers can pass through the road without getting disturbed, and both sides of roads, so that the noise of the traffic does not disturb the animals in the village, in the forest there. Actually, the tendency of tigers is to travel from one reserve to other reserve. And when we make roads, we make bunds, and we cannot make simple underpasses for animals. For cattle, we can make underpasses because they are directed by human beings, by men, by their owners. But in forest, we cannot make underpass and expect all the animals to pass through it, and from a given a given limited area. So the whole road was lifted up, and a sound barrier was created. It has been created. It's the first time done in India like this, and this is what is the effect, or mitigating the effect of road after it has been constructed. During construction, of course, there must be some noise, some pollution or something. Then comes flooding. How I can give you two good examples which I faced, and both were in the same project by chance. In one case, my initial about 7 to 10 kilometers of the road stretch was passing through a urban area, and in all this, in full 7 kilometers, there were only two existing culverts, which means that there were only two valley type of valley creations, and it was not very densely populated area, some outer skirt, but some hotels, some colonies were developed. In one of those existing culverts, which we continued and for which we increased the size also, there was a pond on upstream side, and the water would collect in the pond, and then overflowing water would pass through the that culvert, and will get collected in a drain some 1 kilometer from my center line, and running parallel to the road 1 kilometer ahead, with offset of 1 kilometer. So it was supposed to be working like that. We made the culvert, we made everything, and the upstream side got flooded in one of the rains, which were very heavy rains in particularly that year. The SDM of that area, he called me, and he started shouting on me that people have not designed it properly, and this has happened, that has happened, and you are not and we are, this is getting flooded because of roads. So I took him. What was happening was that on the downstream side, where this water was supposed to flow and go and meet to the Nala 1 kilometer ahead, was all obstructed by constructions, different type of constructions, small, big, and there was no place for that water to actually, um, go and to drain out. So this was one. So this was causing a flood, and this was not considered, not notified during the design, which is not supposed to be the designer's issue. He has seen a lower portion, he has seen a portion, a point from which the water should cross, and water may cross, can cross rather. He has provided a hole there, but then the channel through which the water was supposed to flow has been blocked. So that caused flood. Another very interesting case where there was a railway line. I mean, it was almost 500 meters away from our alignment. There was a railway line where they have provided a big culvert, and our designers, I don't know what happened. It was there in DPR and what was that study, and they have provided just a pipe culvert just in the front of that. I mean, it was the same channel, 500 meters upstream. So when we reached the site, we pointed it out that the railways have provided a bigger what do you call it, culvert, and we are just providing few pipes. It will not be sufficient, but because of change of cost and this and that, it was not accepted by the authority and by the authority's engineer. So then we made the culvert, and we went ahead. Next rains, other than this rain which I was talking about earlier, that was a record rainfall in that area, and this culvert could not cater to the water flow. Ultimately, luckily my road was not completed, it was only earthwork completed there. So ultimately the water got diverted to some other locations. It cut through my road. It washed away my road and entered into the nearby city, nearby town, and flooded that town. Even a few people died in that flood. So it became a big emergency. And I was, as a project manager, literally arrested. I mean, not literally, I should not use the word literally, but virtually arrested. I mean, SDM asked me to sit in his car and not to move out until this problem is solved. And I was sitting in his car, going to site, sitting along with him, passing my instructions from there only. He did not allow me to go anywhere else than to remain with him and in his car. So it was virtually an arrest for me. So a city, a town, which never got flooded. I mean, there is no possibility of that town getting flooded because owing to the topography of that area, got flooded because of this road, because the wrong design of this road. So there it brings us to the importance of why should we take care of flooding, and then the hydrological. I will come to the hydrological thing also. Then damage to crops and fields, of course, we do it. We do it by not only by taking over those roads, those fields, but also sometimes cutting their crops, standing crops also, and trees, lot of trees. The local business, of course, local business normally gets positively affected by road construction. Effect due to transportation, especially in road projects. We bring a lot of soil from nearby borrow areas, and lot of transportation happens where it never happened. It was never supposed to happen. In the villages, in the fields, in the smaller roads, all the trucks start moving, and a lot of trucks start moving. So that has to be taken care of, and that is we'll see later on. Then local accessibility issues, as I discussed the perforations required, and this they have called thing. Then we come to futuristic environmental concerns, the long-term concerns, geotechnical and geological effects. These are not very serious for road construction, but sometimes when when the studies are not conducted properly, they become like that, and especially in bridges. Bridges are not considered as heavy civil engineering structures. They are not considered as from geotechnical point of view, from geotechnical engineering point of view. So they are very shallow foundations with respect to what happens in dams. Dams are considered as heavy structures, but when the road is constructed in hills, then this factor becomes very important. Now, I will give you an example of sinking. What is sinking? If I can explain you, what happens when the road is made in a hill is that from the alignment to certain extent we study the slope, and we found out that we calculate the slip circle which passes on the and fails the slope, right? So slope should not fail, and that material should not fall on the road. So what we do, either we cut the road, if possible, we cut the road in a mightier slope so that that slip circle gets mitigated, or we reinforce that particular slope, and our reinforcement crosses that slip circle line, the imaginary line of slip circle. So it becomes strengthened. But this is happening, especially what I have seen there in this Char Dham project in Uttarakhand. The slope has been, duly stabilized, but now my slip circle has shifted back. It has gone back from the originally designed slip circle. It has gone back, and my slip circle is now passing from under the road. Up till now, I have designed it to not to pass from under the road. I have designed it and reinforced the slope so that it does not fall over my road. But now my slip circle has gone back, become bigger, and it has started passing from under the road. And now when the failure has happened, my road itself got washed away. And this just, such sink, many structures have been identified now where this sinking is taking place, and it has become a major problem for both for the authorities and for the contractors to manage this sinking thing. And they have created a lot of contractual issues also, this sinking effect. So that, how to deal with it, whether it is the responsibility of contractor or not. And contractor is, spending a lot of money on maintaining this and reconstructing this area. So, and of course, any slope on a hill, when it fails, it takes away with it a lot of things, a lot of change in geology, a lot of change in local environment, on the human beings of that area. So it is a long-term sustainability issue happening due to road construction. Right? Hydrological effects. Few examples I have just given when I was explaining flooding for hydrological effects of this thing. There are some long-term effects also, because the direction of flow of water changes. What happens is the ground is, a channel is formed in the ground when it found the slope from the two sides meet each other, right? So what we do is we provide a culvert in the channel, but the slope of the ground is not 2D, it's 3D. The slope is on all the directions, right? Give me a moment. My battery is low. Just give me a moment, please. Sorry, my excuse. I mean, accept my apologies for that. So I was talking about the slope of the ground. So all the water which is sloping on the ground does not go to the channel. But now there is a bund on one side. So what will happen that this water which was going, going through on this side will also start coming toward the channel. All these have got a long-term effect on the overall ecology of that area. So of course, the water which is getting collected into the channel, the hydrologists take care of that, and they take all the measures so that the water goes on the other side. But what about the water which was flowing on the fields on the downstream side of the bund of the road? That pattern again changes. So these are very, very minor hydrological happenings which affect the overall environment and ecology, and of course sometimes not in a positive manner, and have got an effect on overall sustainability, which has to be taken care of. Agriculture, especially when we are doing cross-country project like road, a lot of agricultural land is taken for construction, and which means that how will we eat when there will be no agricultural lands available, when there will be no agriculture? So there has to be, up till now, this has not become, up till now, luckily, in India, this has not become a problem that so much of roads have been made that agriculture starts getting affected. But then there are secondary effects of road construction. The big projects which are being taken care of, which are being planned now, are being planned with industrial triangles or industrial areas developed along them, along with them, and then like dedicated freight corridors, like your expressways, like Bundelkhand Expressway in UP, and some defense corridor has been planned, which means all that area will be industrialized, again taking up agricultural land. So that's a secondary effect of road construction, for which this we have to see that there is a good balance, and not a good agricultural land is not going, although it is being taken care of, but it is actually not happening every time. People see cost of the land. They don't see the land use pattern. My next point here, that the land use pattern is getting changed, and land use pattern, if it's changed, it changes from rural to urban, or from agriculture to industry. It brings a lot of changes in terms of pollution, in terms of human beings, in terms of the population growth, and then meeting the requirements of all those developments, and has got a very dire effect sometimes on the sustainability of human beings as a whole. Then quarrying, of course. Quarrying is a very important factor as far as road construction is concerned. There are two types of quarrying. One, as I said, the soil, which is taken from local areas, and soil is taken, one from pond and two from the land, the fields. So it can be an agriculture field also. It can be a non-agriculture field also. Which is where no agriculture is happening. So that type of lands also are there. So if this quarry, and most of the road, rather all of the road is made of either soil or aggregate. Either soil or rock, and both come from quarrying. So making a road and then cement, again depends on quarrying. So how to cater to this, how it is catered, how the effect of quarrying is reduced, due to quarrying is reduced, how the overall quarrying is reduced, we will talk later on. Then local accessibility issues in long term, as I said, there is a very thin line. So it was short term there, long term here, and human development in long term, which we already talked in between. Then we come to the modern mantras of sustainability, which come in your mind when you sustainability, which you will be able to understand and and digest very, in a proper manner. So reduce. Can I interact with the students? Is it possible to interact with the students?
Yes, sir. In the end, we are going to have a question and
In
answer.
the end, in the end only. In the end only, or even now, if I ask them to say something.
So we can have a question and answer session right now.
Okay, so I want somebody to tell me that in a road construction, this mantra reduce, the mantra number 1, reduce. What can we reduce? Can we reduce the crust? Can we reduce the length of the road? Can we reduce the width of the road? What can we reduce? Can anybody come forward and help me in telling that what can we reduce to make the road more sustainable?
We can reduce the use of more fossil fuels in construction of road.
Fossil fuel.
We can
Okay.
use alternatives here.
Right. Okay. Fine.
So we can optimally design the roads in order to reduce their length.
Length. Hello?
Yes, so we can optimize the structure of roads, the network of roads, in order to reduce their length.
Reduce length of the road. I mean, if you have to go from one place to another, you have to reach there. Now, if you reduce the length, how will you reach there? Hello?
But then if we sir design the network of roads in an optimum way, we can reduce the total length, overall length of the road network.
You mean the curves? You mean the curves?
Yes, sir.
Okay. Right. Yes, it can be done. That way it can be done. No issue.
Also
But it may have
use,
other issues. But yeah. Next.
sorry. I was saying that we can reduce manpower also. We can go for automation like these days.
We have 130 crores. We have got 130 crore people here. Why we need machine when we have manpower? Or
Sir,
machine will pollute. Machine will pollute. They will eat fossil fuel. So why not use manpower then? I mean,
sir, because we have
I'm just asking you.
So we have to compete as well, right? Globally.
We are talking about sustainability.
Yeah, for sustainability also. Sir.
Will it be better to give more employment to more people than to use machines? I mean, a communist way of thinking to it, on it.
Agree, sir.
Anyway, let me come to what we can use. First thing is, as I discussed earlier, also durability. If we can increase the durability, we can reduce the maintenance requirement. And there are two things which are being done right now. One is the use of perpetual pavement. The first project which is happening in India in perpetual pavement is the Delhi Agra Expressway. This pavement is designed for 50 years, and the structural requirement is the strain coming on at the bottom of the asphalt layer. The bottom of the asphalt layer, the strain which comes there, that is to be controlled by the overall design of the road. So although the design becomes a little bit thicker, but that too is taken care of by using different techniques. But the overall strength of the overall life of the road has been designed for 50 years instead of 30 years. So if your durability increases, of course, requirement of overlays gets delayed to a very high extent, and requirement of day-to-day construction, day-to-day maintenance reduces. So it increases into the sustainability of that road, sustainability and effect on the environment also indirectly. And then use of modified bitumen. Bitumens are modified with rubber, with crumbed rubber, with the polymers, and with the natural rubber. So what happens is when we use modified bitumen, the maintenance requirement, durability of the road increases. It becomes less porous and more resistant to high temperatures. In India, 40 degrees centigrade is just nothing. Everywhere it happens, but there are places where it goes 45 plus or even up to 50. So the bitumen, the normal bitumen without modification, you must have heard because all of you are civil engineers, must have heard the word softening point of bitumen. The softening point of bitumen is increased by using modifiers in the bitumen, so that they can sustain the heat and become more durable, and thus reducing the maintenance requirement. So these are the two things which are generally happening in India. Other things are also there. Let's see. Then we can reduce the energy input. Whatever energy we are putting in making a road, we can decrease that energy. How? First, one technique is warm asphalt. So the asphalt is normally heated up to the temperature of 165 degrees centigrade. And I mean, even up to 170, depending upon type of bitumen. If this temperature requirement can be reduced to near to 100 degree or 90 degrees, something like that, then of course we have decreased the energy gone into it, and thus a lot of fuel and a lot of things like that. The basic requirement why we heat bitumen, let me explain it here only because it will come into picture many times in my presentation. Why we heat bitumen is that we try to increase the viscosity of the bitumen so that it covers the aggregate properly. It spreads and covers the aggregate properly. And this mix of bitumen and aggregate is called asphalt. So to make a good asphalt, we need a bitumen and a material which loses its viscosity at the time of mixing, and then the viscosity increases at the time of use when the temperature goes down. So that it remains intact, right? Something like glue. Glue, when it's air. When you expose it to, take it out, it is liquid. When you spread it, stick the things, it gets dried up. So, and it becomes hard. Similarly, here it is heat. So when you heat it up, it gets less viscous. Less viscous, and then it spreads, and then and mixed, and then. So warm asphalt at the lower temperature, if we can add few chemicals or some additives into the asphalt, which reduces its viscosity at lower temperature, and to the extent that it can be mixed with the aggregate very well, it coats the aggregates very well, then it will reduce. And there are techniques which are, although warm asphalt is still under trial, but it has started coming in use. In India, not much is used, only some trials have been done, but foamed bitumen, now it has started coming, catching pace. Foamed bitumen looks something like this. It is actually some cold water injected into hot bitumen, a very small quantity of cold water injected into hot bitumen, which makes the bitumen to swell and increase its volume. This temperature of this bitumen is not 165 or something. This is, at considerable low temperature only. Then it swells. This chart explains a little bit. If you see here, this is the bitumen line, and this is the water line coming in. And here it is injecting, the water is getting injected into the this thing, bitumen, and foamed bitumen is now spread over the aggregate, and this is mixed with the aggregate. So the same thing, that when the volume increases, volume of the bitumen increases, it becomes workable while mixing with the aggregate, more workable. So it serves the purpose at lower temperature. So this is one thing. And then comes in situ recycling. Okay, I have kept, before going to recycling, I have jumped directly to in situ recycling because my first mantra was reduce. But so let me recycle. First of all, the recycling I will take up later on. But let me tell you something a small bit about it. that the material which has already been used for the road can be dismantled and reused to make road again. So one thing is that you dismantle this material, take it to the plant, then mix it and then bring it back. And one thing is when you recycle it then and there at site in situ. So this makes this sustainable practice even more sustainable. Let me show you one video. Tell me if it is visible to you or not, so that I can change the way. Is the video visible?
Yes, sir.
Yes. You see, there is a chain of machines, and this is milling. I will tell you more about this. This is hot milling going on, and then this material which has been dismantled by this machine. You see that there has been whatever asphalt is dismantled, heated, and at the end, that has rejuvenated. The bitumen which is already there in this dismantled system is rejuvenated with the help of chemicals, and then more bitumen, a little bit more bitumen, and some aggregates are mixed, fresh aggregates are mixed into it, and then it is laid back. You see now. So there is a chain. This is oiler. Oiler is nothing but regenerator. And now after this, when the oiler is mixed, it is simply, this will pick it up through this belt. It has fed it to the paver, and now the normal paver. It has been paved by the normal paver, and normal it is. This video is showing the rollers working behind the paver. So there is a chain of machines which recycles this asphalt then and there in situ. Right. So another thing what we can reduce is input materials. Whatever materials are going in, as you said, length. If we can reduce length, by reducing the number of curves. Although curves are not given to provide them. They are not essential part of a road design, road alignment design. Curves are given only when it is required. So if you are reducing number of curves, you may be reducing, you may be affecting some requirement. So that may not be possible every time. But okay. And another thing is if you shorten the curves, then also you can reduce the length. But shortening the curves is making the road more unsafe for turning. So that will in turn may not turn out to be a sustainable practice. So what we can do is that we can reduce the material. And one very effective technique which is being used now in India also is stabilization. As you all must be knowing, there is an earth fill to make a road, and earth is filled up to a level which is called formation level. The top 500 mm of this earth fill or the earth embankment is called subgrade. And the strength of the subgrade, CBR, now because I'm dealing with civil engineers mostly, so I can use this term. Earlier I planned I will not be using CBR, but anyway. So the top 500 mm of the embankment, whose strength measured in terms of CBR, determines the overall crust of the road. If the CBR value or the strength of this 500 mm, top 500 mm can be increased, your crust thickness can come down. If it is decreased, the crust thickness will go up. So normally, in India, if you design with 5% or 8% CBR, you will find that soil somewhere out there. And if it is a good soil, 10% CBR. If it is a gravelly soil available, then 15% CBR. That's how it is designed. More than 15% normally we don't design, we don't allow. But if the soil is of 5 to 7% CBR, and you can make it to be 15% CBR and then that can be done by stabilization. Then this stabilization can be mainly chemical or mechanical. So you can read. You can go to my LinkedIn profile, and where I have given a case study for mechanical stabilization, which was actually done. So it is like mixing other aggregates, other type of this thing materials into the soil and making it well graded so that its strength increases. So that is one thing. Then it can be done with chemically. It can be done with cement, lime, fly ash, or other chemical additives which are being developed. Now our Indian Road Congress has started allowing so many additives now, chemical additives also, which are mixed with soil, and CBR value increases, and thus the overall crust comes down. But the aspect, there is a durability test. When there is a stabilization, there must be a durability test. The durability aspect when we use stabilization must be taken care of because there is a fatigue. There are other factors like weather, water. They affect the strength in long term. So that durability factor must be taken care of when we use stabilization. We should not miss it because it is being done. I've seen people are not testing it for durability and then going ahead for that. So if it is in hilly areas, then freezing twine, and if it is in this thing. Okay, so then there is a very new technology, and only one bridge up till now has been made in India with this technology. This is for structures, ultra high performance fiber reinforcement concrete, UHPFRC. Only one bridge has been made up till now, and in this, what is done is that what do you call it? Steel fibers are used in the concrete, and there is no reinforcement, no steel rods in the concrete, only fibers. So these fibers, I have just noted down some specification of this fiber here. They are of the diameter of 0.2 to 0.25 mm and length of 20 to 25 mm, coated with copper. They're not coated with nickel because nickel is, sometimes reacts with the concrete in long term. Copper does not. So they are coated with copper. And 158 to 180 kg per meter cube of this per meter cube of concrete is the use of this fiber. And it reduce. Now coming to the advantage of that, these fibers, because we are not using the steel, the weight of the fiber goes down to 50% of normal RCC, up to 50%. I mean, of course, may differ from case to case, and the strength goes up by 5 times, sometimes up to 5 times. The fiber strength, the strength of the fiber. Okay, I forgot to note down. Again, I forgot from my mind. It has gone out of my mind also. But anyway, so what happened if the strength increases with of the same section? Strength of the same section increases, then we can increase the span. What does it mean by increasing the span? That we can reduce number of piers. So up till now, the one which road has, which bridge has been already constructed by this technique, there the number of piers were decreased by 2 by 3 of the earlier design, 2/3. So instead of 3, there were 2, right? And there was a trial design for one of the big project. I will not take name. I mean, the person who has told me has asked me not to tell the name of the project, but it's a long bridge where one part is called approach and the other central part is called the main bridge. Approach is also structure, and main bridge, which is cable stayed. The cable stayed part was not made by not planned by this technique. Only the approach part was planned. Again, all the 60-meter spans were increased to 90-meter spans. And the cost of the project, of this 3,900 crore project, only applying this technique on the approach part, by only applying that, the saving was up to 350 to 400 crores in a 3,900 crore project. Because the project is very big and this technique is very new, so they ultimately decided that for this much saving, they will. This was 10% saving otherwise. 10% saving is not a small thing. But looking at the importance of the project, overall project, and this technique be new, So they have decided not to go for it. Anyway, but it is a very promising technique. Now you see, number one, we are saving the section. We are saving by saving section, we are saving concrete. By reducing number of piers, we are again reducing concrete, which means cement, which means aggregate, which means steel. All come from quarrying. Okay. Then because the weight is less, the thickness requirement of whatever piers you are providing also goes down. So this technique, I mean, in engineering we call it economical, but I mean, along with being economical, it is also a very sustainable technique, UHPFRC, and very new. Only one bridge in India at present in Maharashtra. And we will find something about this page also. So then other thing is, rightly pointed out, pollution. So now pollution by using locally available material. It means reducing transportation. So if you can use some soil, something available nearby, by transforming it, like the one I said, mechanical stabilization which we did. What we did was that some quarry overburden material was available nearby. We mixed some 20% of that quarry available material into locally available soil, which was just available by the side. That 80% of that soil, we mixed it together and we jumped the CBR of 5% to 15%. My requirement was only 10% CBR. So we mixed 20. I could get CBR of 10% at 10% of the quarry material also, but for practical practical reasons, the mixing is proper or not and all that, we made it to 20%. And then when during actual quality control from the data which came in, we reduced it to 15%. So it was actually 15% of the quarry material which was mixed with a very local 85% of the locally available soil. So it reduced it did not only reduce cost, it has reduced a lot of quarrying requirement, a lot of transportation requirement. So this is one example which we can think of that. And noise controlled machineries. Now, of course, now the Japanese machines and now even German machines are coming, which have got very low noise, and the generators with noise covers, noise casings have also started coming, so that no noise. It has been already in practice. Fuel efficiency. Fuel efficiency can be increased by adding additives to the fuel. And also there is a new thing now, biofuel. In construction machineries, if the diesel can be viable, more than that is not found very good for other reasons, but up to 30% it can be reduced. And biofuel, is produced by organic methods, by used soil and other agriculture producers, and it reduces a lot of pollutants from going into the atmosphere, and also increases the overall fuel efficiency. Right? It comes into anti-pollution techniques also. So anti-pollution technique, there is one thing, the stack height. If you are making something which is, like generators, so you have to, or the hot mix plants, then your stack heights should be, made at proper height. These things are been taken care of. So and your fuel efficiency means when you burn a fuel, there is one nozzle which supplies air and another nozzle which supplies fuel. The right mix of these two things, in plants, I'm talking about in plants, not in automobiles. So right mix of these two things determines the efficiency, the fuel efficiency. And more efficiently you are burning the fuel, less carbon or less pollutants you are leaving into the atmosphere, right? And as well as less fossil fuel you are using, if you are burning it properly, right? So these are some pollution reducing techniques which are there in which are happening in road construction projects. Then comes recycle and reuse, the mantra 2 and mantra 3. I have mixed them together. You will understand why I have mixed them, recycle and reuse, because here we are actually reusing it by recycling it. So now there are two ways of doing it. Recycling the material used in the road construction, which is already used in the road construction, right? So like recycled asphalt pavement, RAP, we call it short RAP. Actually, RAP is a technique of using or recycling the asphalt pavement, but sometimes the material, the dismantled the asphalt material is termed as RAP. And I know in my flow, I will also make this mistake of calling that material a RAP. So it's a common practice now on our fingertips not to call that material as RAP, right? So, but it is a technique of how we do it. So first, let me see. So for wrapping, for the wrap, this is that material you see on your screen. This material has been dismantled with the help of excavators, right? And you can see the big chunks of asphalt in this heap. Now again, this material is sent to crushers and broken into different aggregate sizes, right? And now this aggregate is taken to the plant and used in the asphalt. This type of material, up till now in India, only 30% of this material is allowed in the rest 70% aggregate has to be fresh. There are incidences where up to 70% of such material has been used, but not on important roads, not on very heavily traffic roads. So for national highways or something, but in India there is one more limitation, that this material cannot be used on wearing courses on the top 50 or 30 mm. This is a major constraint actually, but a road very nearby where I'm sitting now, very nearby, they have actually used it in wearing course, and that road is under study. It's a national highway. I mean, we are studying that road, that what happens to it when it is used on the wearing course. So, but generally by codal provisions, it is prohibited. This brings a big limitation, especially to the operation and maintenance contractors, because if they remove that top 50 mm of the soil of the asphalt, and then again they have to throw it, then and they cannot use it in as a wrap then and there in that same project, and they have to carry it to some other place, then it becomes, it's sustainability rating decrease, right? So, and then comes, and let me first show you cold. Here, directly now another new technique has come into India, that is full depth reclamation. Presently, we are using it in village roads. What happens is that by virtue of the construction quality and the specification, village roads are very weak in India. So normally, if you go to villages, you'll find them, with cracks and with potholes and all that. So now this technique has come where the reclamation is done not limited to the asphalt layer, but full depth. All the aggregate layers and even soil comes into it. Almost 300 mm thick crust is cut and mixed with each other, and then mixed with cement or lime and some chemical additive, and then it is reclaimed, and a bed is made, a formation level is created. And over that, then according to the crust, you can it can be directly asphalt also, and it can be some base course also, and then asphalt. So let us see how it is done. You can see the cement all over. spread all over. As per the requirement.
Sir, your voice is breaking. We can't hear you, sir.
You can listen to the sound. And see the bed. Look at the bed out there. Looks like swine. So all the swine and everything inside and the cement. So and then some you can see this anchor. So that is thing, and then we very quickly have to go to other recycle. Now other part of it, the last part of it, recycling other wastes, the wastes which are produced otherwise. And first of them is crumb rubber modified bitumen. Tires are used, waste tires, which are crushed into small pieces, and then mixed with bitumen. And after mixing it with bitumen, that bitumen is brought to the plant and then mixed with the aggregate. So, although as I said, there are other type of modified bitumen also, but I'm giving examples of CRMP because it is use of a waste. This is one of the recycle and reuse. Then plastic. You must have heard these days use of plastic roads. So all the plastic waste which we throw, it can be used for making roads, for making asphalt. Here, the plastic is mixed with the aggregate before heating. The plastic is mixed with the aggregate and then sent into the burner, and then it gets mixed with the aggregate, forms a coat, and it makes the bitumen to stick in a better manner to the aggregate. But not all type of plastics can be used. This carry bags, the thin plastics, those cannot be used because at the temperature of mixing with aggregate, these plastics gets actually burned. So the plastic which is used here should not get burned at that temperature, at the temperature of 170 degrees centigrade or 180 degrees centigrade. It should actually get melted and mixed with the. So for that reason, all type of plastics are not being used. This is one manual method which is practiced in Tamil Nadu by one PWD engineer. Where plastic is, this is shredded plastic we use there. Then comes a very new thing, waste glass. Waste glass are being used in concrete. Here the photographs are shown for the concrete and also for the asphalt, and waste glass are used as a replacement of sand. Glasses are crushed to the size of 4 mm and below, and then it is replaced with sand. So this is another thing. Then C&D wastes, construction and demolition waste. Whatever material is coming out is again crushed, converted into aggregate sizes and used in basically concrete. This has not been used in asphalt until now. It is used in concrete works, and that too in low strength concretes, not so important concretes up till now. Then other wastes like industrial waste, pond ash, iron slag, copper slag. I mean, since time is running out, I'm not going into detail of this industrial waste. So, well, we can use pond ash, slags of different types in various stages. I mean, in various crust, part of crust, like pond ash is used in embankment and subgrade. Iron slag and copper slags are used in general fill and subgrade, as well as in sub bases and sometimes in bases also, right? So that brings me to the end of this presentation. Have a nice.
Do you have a question?
Yes, sir. First of all, good morning and thanks a lot for such a great session. So, sir, we generally see and read things such as the use of plastic to make roads so as to reduce plastic pollution, as the plastic are non-biodegradable and they stay in the environment. So are they really, like the use of plastic in road construction, really sustainable, or they are still staying in the environment even after being used in the roads? So are they just theories or they really sustainable to the world?
You mean to say whether it works, whether it improves the strength of the road? You mean to ask this? Or?
Basically, like are the roads really working with plastic in them, and are they really reducing the pollution, plastic pollution or so, or they are just theories, not the reality?
So there is no theory and reality in that. If you have picked up the plastic from a waste and used it somewhere, of course you have reduced. So that question is, the answer of that question is that simple. That when you have already picked it up from the rags and you have used it somewhere, pollution is reduced. But the question is that whether we are really using it on the roads or not, and whether the roads made by using this polythene or these plastics are really sustainable, are really durable. Technically, is it okay to use them? Then yes, yeah, it is. Indian Road Congress has already come with a guideline, and they have already also revised that guideline. The only problem now remains is contractual. But what happens is earlier in the first guideline, the first edition of that guideline, it was written that you can reduce the bitumen by the same amount, by the same weight by which you are adding the plastic. Later on, they have abolished that by a circular that this will not happen. This is not the right practice. So now, if I have to use the same thing, and it is not established up till now that whether the actual bitumen content goes down by using plastic or not. I mean, by saying that, I mean to say that whether the properties of the asphalt remain the same if we use plastic and we reduce the bitumen. Okay, so this has not been established up till now. I mean, because not much has been practiced in a professional manner. So the contractual issue what I was talking about is that contractors do not use it because they find it an extra cost, that you bring that plastic from somewhere, shred it, and then organize it, arrange mixing of it into the hot mix plant and all that. So it becomes an extra cost. So if the contracts mention that plastics have to be used in this contract, the asphalt will be made only by using plastic, then of course before tendering itself, it will become an even field for all, and then it will promote using it. So that is the major hindrance. But as far as effectiveness of this plastic is concerned, yes, it is making the aggregates are less susceptible to water and moisture when the plastics are used in that. A little work has to be done, that how to batch it and mix it with aggregate. That is something which is actually under research at present. CRRI is doing a great job there. Ms. Behel is there on it. So that's it.
All right, so thanks a lot.
Thank you, sir. So due to paucity of time, we need to conclude our session. So on behalf of the Infrastructure Management Committee SMHRD, I extend heartfelt gratitude to our guest, Mr. Vivek Singh, who spared time from his busy schedule to be a part of InfraBlaze 2022 and grace the occasion. It was indeed an honor to host you today and gain valuable insight on the topic, which will help the students in their learnings ahead. Thank you so much.